Welcome to the Saiga World Podcast. I'm Mark Hoyer. I'm with Kevin Cameron, our technical editor. This week we're going to talk about the Honda Super Cub story, the little motorcycle that changed the world. Well, it put the world on two wheels. It put the world in transportation.
That's what it did.
In 2005, they'd sold 50 million by then over its life. What did you think of the Cub when it came out, Kevin?
I didn't really think much about it, except that it was a curiosity from Japan, and naturally everyone wondered what would be next. And it wasn't long before Honda was a well-established brand name, because they saw to it. They did it intentionally. Mr. Honda and his partner, Takeo Fujisawa, realized that unless they could produce world standard motorbikes, they could not resist a foreign invasion of motorcycles into Japan from well-established producers who presumably knew a great deal more than Honda did about the business. Well, that wasn't really the case, but what happened was that by 1948, Mr. Honda had established an R&D center, a technical center. The following year, 1949, Mr. Fujisawa joined, who was an experienced businessman, but above all, he was a plain-speaking man of common sense. And it proved to be a valuable combination for many years, because Mr. Honda was all for, let's do it today. I have an idea, let's build it. And Mr. Fujisawa said, that may have been good in 1924 when you were working on your racing car, but we're talking about big money here, and we might want to take some thought before we plunge in. And that combination of urgent innovation and business management and caution turned out to make Honda preeminent among the 200 manufacturers of motorcycles that at one time existed in post-war Japan. So that was one aspect of the affair. Mr. Honda had, as a child, according to legend, run after the first automobile that came through their part of Japan. And he said afterward that the smell of the exhaust was so unlike anything he had ever experienced. It was so exotic and seemed to be beckoning to him to follow, that he ran after the thing until he couldn't continue. He went to Tokyo and determined to grasp this new technology and become a participant. And in 1922, he went to work at a garage, Art Shokai. And fortunately for him, in 1923, there was the great earthquake. The building fell down. All of the employees except the owner and Mr. Honda went home to their families. And the two of them received from auto manufacturing wonderful training that made them more than garagemen. And in 1924, Mr. Honda began to build his racing car, which had a Curtiss OX5 V8 aircraft engine making most of 100 horsepower at 1400 RPM. And we've talked about Curtiss before. He was another one of those thunderous get it done today people. And Mr. Honda went forward to become something of a wheel in the activity. And during the war, he decided he would manufacture piston rings. And 12 miles northwest of Tokyo is the giant Nakajima aircraft engine plant. Mr. Honda's piston rings were rejected. They didn't meet standards. So he thought to himself, could it be that enthusiasm is not the answer to every problem? He went to consult a metallurgist at a university, and the metallurgist said, here are the qualities required for a successful piston ring. So he got right into it and soon was making piston rings that were accepted. The war came to a thunderous end. Everything was knocked flat, and Mr. Honda found that he could buy military surplus communications generators powered by little two-stroke engines. He contrived to attach the two-stroke engines as clip-on motors on bicycles. And soon he was selling all he could get because there was no streetcar, there were no bus services, there was very little of anything. And there is one of these clip-on bicycle engines on display in the Motegi Museum. And it looks just like you would expect. It's a little something or other attached down near the left end of the rear axle. Well, it soon came to mind that the supply of engines would come to an end. They were 50 cc's. They made 1/2 a horsepower. You can imagine a Japanese communications unit during the war in the rainy jungle somewhere trying to start their two-stroke engine so they could broadcast and receive. However, he continued as he had begun with two-stroke engines. Now, the official line that you will get from people who came to Honda without reading the books is that Mr. Honda hated two-strokes. He always hated them, and he was a four-stroke man, born and bred. In fact, when Mr. Fujisawa said to him, you know, my wife said something to me the other night that I think might be important for us. Oh, what's that? Well, she said, our new model, Dream D, which was a much more than a 50. It was a robust two-stroke motorcycle with all the mod cons. She said they smell bad, and they sound like they're not working properly.
I don't know, Kevin. They smell bad. I mean,
well, we don't know what kind of two-stroke oil they
that's
were using.
That's fair point. But what smells better in certain
settings? Yes, there's another whole realm here.
They were really smoky. They were very smoky, particularly at the time.
So Mr. Honda replied, I can engineer around those things. There are special oils we can get that don't smoke. We can do this, that, and the other thing. Mr. Fujisawa said, much simpler to build four-stroke motor. Oh. Now, this turned out to be an important turning point, the first of a number in which Mr. Honda was going in one direction and Mr. Fujisawa was going in another direction. And Mr. Fujisawa said, get on track, man. We're going this way.
Well, let's talk about the landscape for this type of transportation in 1958. It was largely two-stroke. It was the simple, smoky, inefficient. I mean, it was efficient by virtue of being tiny. That was it. And
And it
there,
ran.
and it,
Starts, runs. Big
yeah,
advantage.
yeah, just go, yeah, goes. Very simple. But this was a new way, and it addressed some really specific problems that people were facing.
Which was the first one of which was that Japan's 66 largest cities had been burnt out by the incendiary raids flown by the B 29. And uh, this was widespread all over Japan. Wherever B 29s could reach, they burned down the cities. So that this took place in the last 5 months of the war. One additional city, on average, burnt out every 2.3 nights. So if there was a place where you could find work and it was too far to bicycle, you were up the creek. But if you had a motorized form of transportation, aha, your radius of action was greatly increased, and so were your opportunities. So at the same time, Honda had decided in the middle 50s that the company was going to compete at the Isle of Man. Mr. Honda made repeated trips by air to the United States and Europe to buy machine tools. In 1951, he took $165,000 and went to the U.S. to buy high grade machine production equipment. And people said to him, well, what the great calligrapher said. The poor draftsman blames his brush. And Mr. Honda said, that's okay for calligraphers. I'm not one. I know that we have to have machine tools that can produce our product at a low cost that more people can afford. So the calligrapher went back to graceful figures, and Mr. Honda signed up for $1.3 million worth of tooling off the cuff. He was willing to take, this man was willing to take risks.
What a huge bet.
And they sort of skated right on the edge of the water. Talk about thin ice. They were famous for making their payment at the last possible instant. And nothing ventured, nothing gained. So they were planning already by 1956 what they would do in the Isle of Man and how they would do it. Honda's Research Institute was studying the high-speed internal combustion engine. The remarkable thing about Super Cub 1958 was that it made 9 times the horsepower of the 50cc clip-on engine two-stroke. 9 times the power. Why? Because it peaked at 9,500 RPM. None of this 4,500 RPM Cushman scooter scene. These were practically little racing engines. And by virtue of constant testing, they made them reliable. They began talking about this product because they understood they could never get anywhere selling motorcycles to daring young men in black leather coats. That was the image of the motorcycle. They didn't want that image. They knew that market was quite limited. They needed to make transportation that anyone could use, including women who had spent much of their lives in kitchens and without getting much of a feel for gadgetry. So Fujisawa and Honda went to Europe and they looked at the market there. They saw the Mobi Solex with its front drive with the engine in front of the steering head driving the front wheel through a roller. Pass on that. They went to Italy and they saw the scooters that were coming. from Lambretta and Vespa. Wheels are too small for our world. They will fall into a pothole and poof, an endo will result. And they understood that a certain level of power was necessary. They wanted bigger wheels, but it had to be an automatic machine. No teaching people coordination of clutch and throttle. It has to be, as Mr. Honda put it, the noodle boy has to balance the noodle tray in one hand and operate the machine with the other.
Well, it's what we see in the paddock all the time. None of this clutch business. You gotta tow your tires behind on your whatever. It makes it a lot easier if you don't have to mess with slipping a clutch.
So they set these standards for what they wanted. But the motorcycle, the Super Cub, the clip-on motor was called the Cub. Super Cub was not designed. There were no rows of drafting boards with powerful illumination and a draftsman at each one. Instead, there was a room in which Mr. Honda, Mr. Fujisawa, and several other engineers milled about talking about this, what they intended to build. This project was called Operation Special M.
I like it.
And they looked at 18 and 19-inch wheels, which were respectively the sort of the Italian and the British standards. But they ended up making a motorcycle that was too tall for many Japanese. So they hit upon 17 inches, 2¼ inch tire section. And Mr. Honda was shown various mock-ups. And one of the European manufacturers that was doing well had the fuel tank just behind the steering head, and Mr. Honda didn't like that. He said, stepping into this bike has to be completely easy with nothing to snag your clothing on or to impede your heedless natural movement. So the fuel went under the seat. And the engine was the responsibility of a young fellow called Daiji Hoshino. And in overall charge of the project was Toshiro Harada, whose name comes up again and again in later times, having been manager on the CB 450 Twin and then the CB 750 4-cylinder. So
CB 450, that was the one with the torsion valve springs, was it?
Yes,
not?
sir. They also built a racing engine for automobile with torsion springs. It was a sort of an interesting sidelight. It wasn't continued.
We should do a podcast. It's Honda's interesting sidelights because we could really,
Yeah,
there's plenty to talk about there.
there certainly is.
Well,
So-
I mean, so the 50, one of the principal qualities that you're talking about is that ease of stepping over, just like your Vespa, which had, set the pace in Europe, but it had leg protection and it took the engine and laid it down. So all that nasty business is kind of below the belt line and you just step on and away you go.
Yep.
Yeah.
And one engineer was given the job of creating a clutch that would be unseen and unknown. And what he came up with was a device which, when you moved the shift pedal, the first part of the stroke lifted the clutch, disconnecting the engine from the drive system. And the second part of the stroke rotated the shift drum, moving the gears to engage the next ratio. And then when you took your foot off, the shift drum stayed where it was on its detent, and the clutch re-engaged, and you continued on your way.
Weird
And
sidelight for me here. Sorry, but I got
yes,
to put this in there.
oh yeah,
1958 Triumph Trophy. Uh, I owned one of those 650 first year for the alloy head, single carburetor. It was the first fork that had damping in it from Triumph, as I understand it. It had a little bit of rebound damping apparently. Um, it had slick shift, and my slick shift was still intact, so there was a rocker inside the gearbox with a little roller, and when you shifted it up or down, it would disengage the clutch.
mm,
And mine actually worked. Usually people took that out, but mine worked. And you could, with some difficulty, you could start from a dead stop and slip the clutch. It's just that the band of engagement was a little too abrupt.
yeah,
But shifting up and down, it was really no problem. And also, it was a boon to the races that you had to start with your clutch hand on your head. The desert races, you had to be like this. Your bike could be running, but you had to be in neutral. And so for
mm,
those guys, they could stick their foot on the gear lever and you use the dirt as your clutch in that case. That's your friction zone. So you just
yes, indeed.
hit it and away you go. So anyway, slick shift, opening up the Triumph motorcycle experience to extra 100 of people.
Yes, I don't want to rush into the rest of this story without recounting my amazement at how Japan, basically a feudal nation, in 1853, was able to make a nationwide decision to industrialize. This was not something accidental. Japan had already learned about firearms through Portuguese traders and had developed her own excellent firearms manufacturing capability. But the firearms were so disapproved of. A fry cook from the seaside must not shoot a titled uh, person on horseback. This is completely improper. Despite that, Japan decided not to let itself fall into what had happened to China. The Western powers had looked upon China as a disorganized place that needed their guiding hand. And China was chopped up into zones of influence, British, German, US, etc. And Japanese leadership was terrified that Japan would be next. Here came Commodore Matthew Perry in 1853 with his 4 black ships saying, "Knock, knock, I know you're in there. We're coming to trade with you, like it or not." So they went about it in an extremely methodical way. They brought in foreign engineers and designers, and they mastered the Industrial Revolution to such an extent and so quickly that when the Russian fleet was sent to punish them for some imagined real or imagined misdeeds, the Russians met the Japanese fleet at the Straits of Tsushima and they were destroyed by the Japanese fleet. They had learned to make enormous guns, to bore them, to liner them, to aim and serve them. And this was imposed upon a very traditional culture. And I think that's really remarkable.
I mean, Germany did a similar thing in terms of education, right? They made a shift in the 1800s where they were really leaning on
Well,
technical education.
the Iron Chancellor established a system of higher technical universities where such things, such arcana as manufacturing engineering. Let's design this product not only to work, but to be easy and low cost to manufacture. Yes, and that was the work of the Iron Chancellor, um, who is so hated by many on the left to this day. But he basically told the leadership in Germany, who were just men of the soil, grown important. He said, "You want to be a nation? You want to be maybe number one nation? You're going to need a workforce that can read. What if they read the wrong thing? Well, that's a chance you're going to have to take.
I can't read the wrong thing, man. Come on.
And but it'll cost a lot of money. So will getting defeated by Napoleon, which nearly happened. I mean, it was want to become part of France? Oh, well, I suppose not. So, yes, the Industrial Revolution had a momentum of its own. You might like the idea of continuing to sip a tall, cool one on your porch watching the sun go down, but here, here comes the Industrial Revolution. That smokestack wasn't there yesterday.
Yeah.
So Japan was really a big surprise this way because they realized that to be an independent nation in the times that they could see were coming, you've got to have your own industry.
Yeah, SKB shotguns. That was like late 1850s. Sakaba, I think is the guy's name. We have an SKB over under 20 gauge. Japanese made. They've since moved to production. They got acquired, and I think they stopped making guns in Japan in 2010 and went to Turkey, as many gun makers have. But
well, during the war,
SKB, it's a beautifully made, beautiful shooting gun.
Marvelous. During the war, Yamaha made propellers instead of musical instruments. But this whole thing, this industrial changeover, has made people like Mr. Honda, and he actively rejected the past when he was asked to a one of these stuffy meetings where you must obey the dress code. He came dressed for work. He said, "I work. I am a worker. This is my working outfit. If you don't like it, get used to it." And so they carefully planned Super Cub to be the vehicle that it became, but it was an enormous gamble because we all know how many times people make plans. The plans are extremely plausible. You look at every point. Yes, this one makes sense. This makes sense. And then it's a flop. So ultimately, you're saying, we've tooled this thing and we hope people will buy it, but maybe they won't. That's business. So when the machine Super Cub was revealed, the main dealer in downtown Tokyo sold 600 the first day. And it's been a hit ever since. And we've all seen those marvelous videos of an entire family in Burma or Thailand or anywhere around the world. Some of the people sitting among the others are holding crates of chickens, and somehow
no, it's remarkable the centeredness of people who have grown up doing remarkable things with small transportation. It's just wonderful.
It is.
It's just rebar and furniture, and we saw a family of five. We were in India, Jeff Allen and I, when the unit construction 500 Royal Enfield was produced, released, and we were riding around doing photos, and we were doing a photo shoot, and this family of five came by on a like one of the 100s, like a Hero or something, came motoring by. Family of five. This little girl sitting on the gas tank, holding the handlebars at the very front, the man operating it, and then a woman, a kid, and then the woman sitting side saddle with the sari guard, holding a bag of rice and holding a baby. And what a way to move the family. You couldn't help but be close. So it's amazing how adaptable people are and what a great job you can do with what you have if you focus on it.
Well, when Mr. Hoshino, the engine guy on the Super Cub project, was asked, uh, how can this engine make 9 times the power of the first engine Honda produced? He said, this engine is the outcome of our preparations for the Isle of Man. Because what other engine, what other production engine in the world in 1958 was peaking at 9,500 RPM? Nothing. And they made it stone reliable. And in fact, that may have been the origin of Honda's 2,600 hour durability test, which was, I learned about that from the American Honda's racing manager. And he said he didn't know whether that test was still being used or whether design had moved far enough forward that basically it was incorporated in the design process. But Mr. Fujisawa looked at the new machine and he said, oh, we will sell 30,000 of these. And the other engineers looked at him and they said, 30,000? Oh, per month. And by October of 2017, 100 million had been sold. That's 8 years ago. They're still making them. It is the most produced vehicle in the history of the world.
Well, that means from 2005 to 2017, they added 50 million. Because in 05, that's when they hit the 50 million milestone. So that's pretty remarkable.
Yeah. It's like 4 million a year. So all the preparation that they made and the study, Mr. Fujisawa and Mr. Honda going to Europe, the discussion of those people in that room, this motorcycle was not designed. They created it from their ongoing discussion day after day until they had what they thought the market required. They weren't thinking about motorcycles or motorcycle people. They were thinking about transportation and everyone who needed it. Good way to think. So it's a little 2-valve engine, air-cooled. Originally, the cylinder and the head were iron because it eliminated valve guides, valve seat inserts, an a cast aluminum cylinder, and an iron liner. These features later were added in 1966. But what this motorcycle did was it bankrolled Honda ambition. Already in 1954, they were constructing a plant in which they hoped to build trucks. This steady source of income enabled them to go to any machine tool manufacturer in the US or Europe and say, here's my order. And when Edward Turner, the Englishman who designed the Triumph Speed Twin, which was first produced in 36, 37, a prominent person in the British motorcycling scene, went to Japan in 1960 and had the tour. And he came back to Britain and he wrote a report. I know we've talked about this in a previous podcast, but it bears repeating because he gave warning. He said, these people are using the latest manufacturing techniques to provide features that we can't provide at a lower price than we're charging for the rather antiquated models we offer. Oh, there's something from, what nonsense. Because the terrible thing about being first in the Industrial Revolution, because bear in mind that in the late 18th century, there was Newcomen using using the vacuum created by condensing steam to make a suction engine that could pump out mines. You dig a hole anywhere in England and it fills up with water.
Weird.
That's a
Yeah.
well. And you dig a mine and it's going to be uninhabitable by virtue of being full of water. So they needed pumps. And what had gone before was, of course, mine ponies going round and round in a circle, underground, spending their whole lives underground, operating mechanism to pump out the mine. And Newcomen is regarded as one of the leading characters in Britain's Industrial Revolution. When you're first with the Industrial Revolution, you know that you're the teacher. You're helping these lesser nations whose industrial revolutions are pitiful, wilted little seedlings. And if you don't watch what they're doing, they will grow, as Honda did and the other Japanese manufacturers, to be able to do things you never dreamed of. And so Edward Turner's report was ignored, and they had to ignore it because they didn't have the credit with which to go to machine tool companies and say, I'll have that one and that one and that one, which Mr. Bloor was able to do with money that he had made in real estate. I visited the engine machining line at Bloor's place early in this century, and there were all these machine tools with automatic transfer line moving the parts from one machine to the next, and each shift was operated by 2 people. It was not a situation where there were 800 machine tools on the production floor and people rushing this way and rushing that, pushing castings on little carts, with a trained machinist at each mill, at each lathe, at each grinder. No, that was all built into the system.
Oh, you watched it. I watched it happen at Royal Enfield. I went to visit in '08, and they were 2 companies that it appeared at the time. There was the traditional line, still making the Bullet 500 largely as it had been since 55 or so. And it was a big, dark, messy place, and guys were bolting things to a plate and then grabbing a big, lever to pull the quill down, and cutting fluid was hosing off on it. And then you went to the 500s, to the new 500, the UCE side, and it was brightly lighted, clean as could be. Guys are wearing white shirts, and the engines are on a line, and they go to get the cases put together. CNC sealant, a machine just lays a perfect bead on the engine case.
It's like a pen. It's like a wonderful pen that never runs out of ink.
Just crazy awesome. The vision that it takes to put something together like that, and having a reference of saying, like, let's see how guys do this. Mr. Honda goes to England and America, and if you went to Harley, you would have seen the guy like beating frames with a hammer, and as they did it when they were doing their stiff bronze welding.
To put the tubes into the machine
having a cast lug with holes in it for the tubes, and you put the tube in, and then they would stick it into a forge, basically a pit of probably coal, and pump the air, get it real hot, and then melt that stuff in there, and that was your frame. And then it would be heat distorted, and they'd have to try to hit it with hammers and then big bars to tweak them into into true. And you can go and look at that and say, okay, that's how they're doing it. How do we get all those steps out? And it's wonderful to have a reference, as you're saying, you're going in and you're starting fresh, and you can say what's good or bad about what's happening and make your own decisions.
And which Yamaha model is it that the frame is two pieces and there's no welding at all?
Yeah, it was the FZ09, later MT09, and
Yeah.
they're not the only ones who've done that.
No, not the only ones, right?
But yeah, that was so that's the Yamaha frame, and it's two halves that are
Right and left.
right and left, that are very accurately cast, controlled fill, basically net size. There's not a lot of messing around, where a lot of casting stuff, you make it too big and then you machine off the stuff that's left over. You can get the shrinkage pretty close. This is super accurate. Steering head, two pieces, break off bolts that bolt that together. And you essentially had a finished frame out of the mold, kiss the machine here, and maybe it's some engine pickup points, as I recall, and they bolt it together, and there's no welding, no other.
Done.
Just done. So you had a modern Japanese motorcycle with that wonderful engine in it, and a great looking, beautifully finished chassis, a motorcycle made in Japan that was extremely cost effective.
That came in steps. In 1980, Yamaha sent square tube aluminum frame test articles to the Amsterdam Racing Center. And Kenny said, every day we ran those bikes in tests, they cracked. And constant communication with Japan resulted in improvements. The joints became more organic rather than just being two pieces of square tubing stuck together. The material was improved, the welding techniques were improved, the design was improved. The racers eventually were steering head and rear swing arm uprights were machined from solid, and then the rest was either sheet metal or extrusion. It all had to be painstakingly welded together. And gradually they reduced the number of welds systematically. Now, one way to look at this is to say they sent home the people who formerly did those jobs and said, you're retired now, here's your pension. This is a dilemma for modern life, no question about it. But that's what happens, because if Company A is doing this, Company B cannot thrust its chin up dramatically and say, not for us. We're going to maintain hand craftsmanship. That means we're going to go out of business.
Yeah. It's interesting to me, being on the consumer side in the 80s. You had your sprinkler pipe frames as, sort of featherbed. We got rid of lugs and all that, but you still had a lot of steel frames running around. But the look of trickness was eventually a twin beam aluminum frame. And welds were the trick part. Like you loved that because
some of them were so beautiful. Yes.
Well, they were beautifully done, and all the steering head was all welded up. And then if you got really an exotic looking swing arm that had been built up out of parts, you just thought, man, this is amazing. This is the future.
RS 250 Aprilia Racer.
Yeah.
Very organic, beautifully shaped mainframe and swing arm. And my heart melted when I saw those things. I just thought, this is art.
But it's a laborious way.
Yes.
To make
something to be sold at a price.
Well, sold at a price, but also just to make it. We've progressed to 3D printing, and you can just make the design, and it's laid one little molecule at a time, essentially, and you can just get a very complicated part with relative ease.
I went to my then editor, David Edwards, and said, one of the Norton upstarts, Norton Reborn, Mark II, Mark III, Mark IV.
55.
Yeah, is having a big intro, and I'd like to go to it because they're going to show this engine that's supposedly designed by ex Formula One people. Why are they ex? Were they fired? Were they incompetent? Um, so I'm installed on an airliner. I go over and I see it. And the part that I didn't realize was important was this motorcycle had a cast frame. Now, no one would dare to cast an aluminum frame prior to the new casting methods that came into use around the year 2000. They found that the defects regarded as inherent to aluminum castings were not inherent at all. They consisted of the layers of aluminum oxide that form on hot aluminum exposed to the air being incorporated in the casting. Break on dotted line. Failure guaranteed. So what did they do for all
It's like
those years?
let's call it the frosting in a cake, right? That's what it is. It's the frosting in a cake. The cake is homogeneous, and what you'd like to do is cast a piece of cake that's, for your wedding, and it's 18 inches tall, but you can't do that. You can't bake it. They figured out how to bake, theoretically here, but bake the metal without accidentally putting in entrainments, as Kevin's talking
The
about.
entrainment of these oxide films. And in many cases, the new molding method was to fill from the bottom and to fill gradually so that it would push the films that were not desired on top of the metal and then push them out the sprues at the top.
Heated molds.
Yes, all these things, all these details. This is what our society is based upon. All these details. So, in this way, this new method of casting made a cast frame possible. And
Kevin
I
was
first
talking,
saw it.
Yeah, Kevin was talking about the Norton Nemesis, I'm virtually certain.
Yes, that's correct.
It was
And
a
I
V8.
went over to see. I went over to see that crazy guy that was
Al
pushing
Melling.
the project. Yes, Melling, and I asked him a couple of questions about a V10 Formula One engine, and when let's say the answers were unsatisfying, I concluded that he wasn't the source that I might have imagined him to be. But he was. He was quite a jolly character. Anyway,
1500 cc V8, purportedly 260 horsepower, and then that prototype still exists, and
there's also a 4.
Uh,
There's a 4 also with
well,
3 spark plugs per cylinder,
oh well,
which sounds like bad combustion to me.
it does, yeah.
But there it was because these new casting methods originated in England at one of the universities. And it's not bad to have a few universities about you. We may need this clever ideas that come from such places. Anyway, the cast frame is now a standard in the industry. It saves weight, it saves labor, it saves money. It enables, just as the Super Cub of 1958 enabled more people to have transportation. So price control on modern motorcycles makes them available to more people who want them. So I think it's marvelous that a concept which worked in 1958 continues to work, and it has not become a 400-pound complexity. It's still simple to use, and this I'm pleased with this because something that works continued to work. What sold it was the fact that it did the job. Not that it had the latest gadgets on it, but that it provided reliable transportation that almost anyone could use. And of
It's a
course, it made Honda into a worldwide corporation because the Super Cub has been produced in many nations. Wonderful.
and it was a blueprint for, well, let's say it set fire to the American motorcycle market because it exposed so many people to the pure fundamental joy of moving on two wheels. It's affordable, it was cute, it's approachable, easy to ride. And once a 50 wasn't enough, there were many other options, and
Yes, there were.
Honda was there to build that stepping stone. You know, Peter Egan talks about, like, well, there was the 50, but then he had a CB 160, a 400, a 450, a 500, or 550, and he just goes up the chain of all the Hondas that he owned over the years, starting with, a 50. And it was the
big
blueprint.
leap.
Yeah, it was a blueprint as they expanded to the Trail 90. S90 was, a similar type of laydown engine. Trail
And
90.
a lovely little motorcycle, S90 was.
Yeah, Trail 90 was remarkable. I bought one. I bought a 69. It still had the leading link front end. Friend of mine, Bill, I don't remember what year his was. I think it was overhead cam. But we rode those probably 10 years ago now, 15. We did about 110-mile off-road loop on our Trail 90s.
Yeah.
And barely used any fuel doing it. Peter
Yes.
Egan bought he bought it in 1977, a Honda Cub, Super Cub, and pitched a story to Cycle World where he was going to ride the Honda 50 and his friend John Oakey was going to ride his, fancy Italian racing motorcycle or racing bicycle, this literal 10-speed. And they were going to ride to Pikes Peak in Iowa or wherever the heck it was. But, and they were going to see which is more economical. And Peter Egan on that 50 went 303 miles and used, the math worked out to 168 miles per gallon. I think John Oakey's comment was like, you can't make a motorcycle gas tank leak that slowly.
Yes.
It's incredible. And the blueprint continues. We have the 125s now, the Trail 125 and Honda Groms, Navis, thinking about fun, transportation, approachability, size, economy. They just run and run. They're just quiet as can be. And you still shift the Trail 125 the same way you did a Honda Super Cub. And they're great.
Yeah.
I think my son, who's now 12, over the years has probably put a few hundred miles on Trail 125s just going up and down the street.
Well, of course, a number of the people who were engineers on the Super Cub went on to other things, just as Mr. Harada went on to CB 450 and CB 750. I'm particularly interested in the leap from 450 to 750 because that was another gamble. Would the American market accept a large displacement motorcycle? Sales of the 450 were not forest fire proportions. People weren't sure quite what it was. I saw a few of them, but not many. But CB 750 was a barnstormer. It was highly successful. And all of these designs were pretty workaday. So Mr. Harada, and ably assisted by Mr. Hoshino, the engine guy, were applying what was being learned all the while at Honda's Research Institute. And it, like the production system, was equipped with the latest goodies. They established an emissions research group early on with 10 people in it. And they looked at all aspects of combustion, just as they had done in trying to develop the Super Cub.
Well, CVCC certainly came out of that.
It sure did.
And they were able to go along without using cats a lot longer than other manufacturers.
Well, the thing that was so remarkable about it was that when it went on the market, it met the standards, and it was not coming from the wellspring of automotive innovation, Detroit. It was not coming from Germany or Italy. It came from Japan. And that is because they studied the matter early, and they realized that there were ways that they could complete combustion. They could make combustion far more complete in the combustion chamber by using certain techniques.
Rather
Later
than burning
on,
it
yes,
in the tailpipe.
having to carry out the trash and burn it separately. So, and of course, when they put catalytic mufflers on the final two strokes in the mid 80s, one of the complaints was that
Oh, yeah, the RZ was notorious.
the heat from the combustion that was taking place, and because it's 30% of the fuel being burned, was being burned in the muffler. So they just stole a march on the others because of this. And by the others, I don't mean Japanese competition, I mean Detroit. And a CVCC V8 was supposedly constructed for evaluation, and the American side said, we'd better do this ourselves, our own way here, because we this is a solution, but we don't know how to get to it. So, Mr. Honda, failing to make acceptable piston rings, realized he had to get real physical insight, actual information. He went to a metallurgist. The metallurgist showed him how to correct his mistakes. That never left him.
Well, that's an interesting, when you said that initially, I'd heard it before, but when you said initially, Mr. Honda was originally getting into piston rings, you think, well, that's actually a pretty good place to start because so many details matter so much.
Sure do.
It's not, this is not like rough casting a frame or stamps, sheet metal stamp frames or something. This is big action in a little zone. So it's good. I'm like, look what he got out of it. Look what he made out of it, let's say.
Progressive attitude he got out of it.
Progressive attitude, and the Cub, it continues to pay the bills, and it pays dividends to people, bringing that ability for transportation and joy, affordability, ease of use, and we see it in all the mini lineup from Honda to this day.
Mr. Honda actually came to this understanding that he would need to spend money on research. For a long time before, a presidential advisor that used to appear from time to time at the place where I was working in Newton, Massachusetts, Gerald Zacharias. Zacharias said at one point, because we were in the education business, he said, education is an industry like any other, and it should be spending 3 to 5% on R&D. And Mr. Honda realized that you can't just design something and then mindlessly crank it out. You have to have a research arm who's figuring out what to do next and how to do it. and also is filled with people who know about the latest technologies, and they can tug at your sleeve and say, "Oh, please, Mr. Leader, will you read this report? You may find it interesting." And once again, Mr. Fujisawa and the engineers were able to prevail against Mr. Honda's boneheaded insistence that he could engineer around the problem of making an air-cooled automobile. The 1300cc air-cooled was running into so much trouble that a busload of engineers went to see the old man, and they said, "We don't want to lose our jobs, but you're destroying the company with this madness. You must not produce this air-cooled idea." And Mr. Honda must have had his arm twisted to a satisfactory degree, because what was put in the place of the 1300 air-cooled? The CVCC engine in the new model, and it showed the way. And then came Accord in 1975 or 76, which was a small economical automobile with many options as standard, so that it was an economical but luxurious automobile. Who had that idea?
Nice
Because
driving car, really, really was.
because a Volkswagen was not luxurious. I've done a few miles in those things in the winter. The one I was riding in, the heater worked like gangbusters for the passenger, but it blew cold air on me, who was driving. So, succession of new concepts like this causes me to remember Bell Labs, which employed something like 25,000 people at one time. And the instructions to them were, if you see some concept or technology or some possibility, explore it. We'll back you. And a lot of the innovation that led to the transistor revolution came from Bell Labs. But eventually it was decided by wiser men that it should be de-emphasized, and it was. So this is a valuable idea, that in parallel with the production side, with the design side, that there should be a research side that is looking into the future and imagining what the possibilities may be. And Honda has always pursued that line of operation.
Well, they laid
And
the foundation with this technology from their racing operation, and they got
yes,
their 9,500 RPM, and they looked at it from the perspective of, how do we make a product to satisfy mass demand for getting around? And it succeeded so successfully that they had to, they no doubt learned so much about manufacturing by selling 600 of those in the first day at the Tokyo dealership,
yep.
and selling so many around the world, where you have to kick it up and you just have to figure out how to build more. You know, Harley's problem in the 90s, really the only problem, well, not the only problem, the main problem that Harley was trying to solve in, 1995 and over the next several years was volume. How do we make more?
How do we build enough? Yeah.
How do we build enough? They were always in short supply.
They had put their shoulders to the R&D wheel more in marketing concept, because by selling motorcycles that were factory customs, they hit it exactly right with their clientele. And that was the replacement for Sportster, in a sense, was to understand that in addition to the touring side, there has to be a place for younger and even many older men in self-expression. through a motorcycle, and it was tremendously successful. So today we know that Ducati are famous for their success in MotoGP and in the marvelous high performance motorcycles that they produce, but their bread and butter is something closer to a normal vehicle, less extreme, more affordable, and Super Cub has been that very thing for Honda for so many years. It has been their heritage income that never stops and has enabled, in a way, that the research arm, which is now HRC, can do the things that it does. At the present moment, Japanese motorcycles in MotoGP are at a low level. Yamaha filled the bottom four places in Austria just now. Last, next to last, etc. Like that was their home. This is unacceptable. But the fact is that MotoGP has become a European series now. And Japan is, of course, looking at Southeast Asia as their next gold mine. And it's hard to know what's next, what direction is correct. But for sure, Super Cub was the correct direction.
It was what a great bet, what a remarkable bet, and world-changing process, world-changing motorcycle for Honda, certainly, which expanded its influence, and then it put 100 million people on the road with a smile on their face, or more.
Or more, yes.
Yeah. Well, thanks for listening, everybody. That's it for this week. We appreciate you listening. You can, we'll say it, like, comment, and subscribe. We love seeing the comments. We will put something together. I will comb the recent comments, and we will maybe do a little either Q&A, or we'll do a section of the next podcast on a discussion of what's happening in the audience and things they want to know. We've had questions emailed in, and also all over YouTube and stuff. So we appreciate you listening, and we'll catch you next time.